Now let's take a look at how we can multiply complex numbers together. Now, what I'm going to do, we're going to put these in trig form, and then we're going to perform the multiplication with them being in trig form. But first, I want to go back and just remind you of what's involved in multiplying two complex numbers. There's nothing tricky about it, really. If you just take z1 times z2, it's just very intuitive. And then you use your distribution, right? 1 times 4 squared is 3, plus 1 times 4i, and so forth. And you get this. That's some people would call this FOIL, right? We just multiplied this out. Now, recall that I squared is -1, so I can immediately replace I squared with -1. And also, take a look at this. I've got 4i here, and over here I've got this thing, which is I. It's got a coefficient over here for the I. Well, let's see what that is. That's square root of 3 times square root of 3. That's 3 times 4. So this whole thing right here, this whole thing is just 12i. And then we put it together with that 4i, and we get 16i. So let's see what we have. Replacing this with a negative, and then this and this that's just 16i. So here's our product right here. This is when we multiplied it out. And you can notice that 4 squared is 3 minus 4 squared is 3. Those go away. And this is our complex number, 0 plus 16i. This is the product, z1, z2. Now, if we were going to plot that, notice we go over 0 on the real axis, but up 16 on the imaginary, and we get a point up here, and clearly the theta here, this angle is going to be 90 degrees. The angle made with the horizontal axis is 90 degrees. Okay, that's our angle. Now, as far as the magnitude goes of this product, this is the product, 16i. Well, the magnitude is just the square root of 16 squared, which is 16. Now we're ready to represent this number in trig form. We've got the modulus here. I think I call this the magnitude. The modulus times cosine 90, right? Plus I sine 90, right there. See? So this is the trig form. But notice this was the product. We converted to trig form. This is what we had. Now, let's look at this. Let's perform this multiplication, only let's transform it into complex numbers first. So let's take this first one. I get the modulus, I get 2. I get the angle alpha, which is going to be arctan of the real part, the imaginary part over the real part, and I get 60 degrees. Now, that's the correct angle because we're in quadrant 1, so we don't have to worry about, adding 180 to it. So here's our imaginary number, or our complex number. Z1 equals the modulus times cosine of the alpha plus I sine of alpha. This is our angle right here. This is our complex number. Now we do the same thing for Z2. And we get a modulus of 8. We find the arctan to get the angle. We find it to be 30. So Z2 can be written this way. 8 cosine 30 plus I sine 30 degrees. So we have successfully written Z1 and Z2 in trig form. Now, let's see what happens when we multiply. Okay, so here we go. We got Z1 times Z2. Well, notice the 2 and the 8, those are going to multiply to give me 16. And then I just go through here and multiply out. Now, it's kind of a long multiplication, but look, I went ahead and multiplied the 2 and the 8 together and got 16. And now we have cosine 60 times cosine 30. There that is. Okay. Then I have cosine 60 times I sine 30. There that is. Okay. Then I go to this next term. I sine 60 times cosine 30. There that is. Right? And then I sine 60 times I sine 30. That's going to be I squared sine 60 sine 30. See? There that is. Okay? Now, notice at this point what we have here. We have an imaginary part, right? Sine 30 cosine 60, sine 60 cosine 30. Both of those have I in front. So what I'm going to do is I'm going to group the real parts together and the imaginary parts together. Now this over here is a real part because this is I squared and that's negative 1. So I'm going to drop that I squared and that's just going to be a negative 1 there. So here's what happens. I replace that I squared with negative 1 and here's what we have. Now I'm going to group this with this. See, the real parts together, and then I'm going to keep the imaginary parts together. Okay, see what I did? I moved this over here with this one, and there it is. See? And then I put the imaginary parts together. See, there they are, and I went ahead and factored out the I. But there it is. Okay, now, let's take note of something here. This might look familiar to you. Cosine 60 cosine 30 minus sine 60 sine 30. Well, that right there is the cosine, for the sum of angles formula for cosine. In other words, this right here and this are the same. So cosine 60 plus 30 is this. This is the expansion of it. This was a formula from Trig early on when we looked at identities. Okay, so I just replace this with that because the cosine of 60 degrees plus 30 degrees can be expanded this way. Likewise, this over here is the sine of 60 degrees plus 30 degrees. So this is the sum of angles formula for sine. This one is the sum of angles formula for cosine. So what we've done is we have successfully perform this multiplication, but take a minute and dig what we have here. This is cosine of 90 degrees. See that 60 and 30? Well, the cosine of 90 is 0. The sine of 90 is 1. So this whole thing just reduces to 16 times I. Yeah, see that? 16 times I. Because this is 0, this is 1i, so this is just 16i. Now remember, earlier when we multiplied these out without putting it in trig form, when we did this earlier, we got 16i. So we got the same thing, converting it to trig form first, or just multiplying it out, and then converting the product to trig form. So now we can generalize a little bit. Let's suppose we've got a couple of complex numbers, and we've got z1, and this is the trig form. Let's suppose we've converted to trig form, and then z2, this is its trig form. We've got the angles alpha and beta, and we want to multiply z1 times z2. We want to find that product. Well, notice what we're saying is that what you do is you multiply the modulus of z1 and the modulus of z2 together, find that product, and then you have cosine of the sum of the angles, cosine of alpha plus beta plus I sine alpha plus beta. Now, that is something that we want to keep in mind. This is very important. This makes multiplying complex numbers pretty easy. Now, let's suppose that we're not multiplying z1 and z2 together. Let's suppose we're just multiplying z1 by itself. In other words, we have z1 squared. Well, just replace the z2 with z1 and you get this moduli, the modulus right here, z1, the modulus of z1 squared. Replace the beta up here with alpha and you get this. And you can go a step further and say, oh, there it is. This is, z1 squared would just be equal to this. Now, you can play around with this a little bit and say, well, what about z1 to the third power or fourth power? And so, and on and on. And you could see that all you do, if you have z1 to the fifth, this would be a fifth here, a 5 here, a 5 here in front of the alpha, and a 5 here. And you can play around with that to convince yourself that that's the case. But that is going to make raising complex numbers to a power pretty easy.